And so here we are, on the flip side of you or someone you know probably taking the fall 2021 AMC 10A, maybe it was the 12A. We're going to get to problem 1 in just a moment. I did want to give a quick shout out to C Eyewear in Glendale. I picked up these in the summertime. I try to find glasses that are a little bit different, maybe trendy, stylish, hip, whatever you want to call it, something that's kind of not like what everyone else has. And I found these there. I looked at several different places, and these were the best store that I found that had a lot of selection of, I don't know, it's kind of quirky, interesting, different kind of glasses. I would say stylish is probably the best word. They also had great customer service, and they're not paying me to say this. I just thought it was a great place to go. So if you're in the market for new glasses in the near future, check them out. All right, so let's get started then. Problem number 1, what is the value of this? Don't spend a lot of time being too crazy, just look at it and figure it out. I don't like to subtract, I like to add. Why adding? Because it's faster. If you add 79 to this, you'll get 2100. Add 12 more to get 91. It's 91 squared, which is 13 squared times 7 squared, because 91 is 13 times 7. Dividing by 13 squared to cancel will get you 49. It is really important that you go through early or trivial type questions as quickly as possible without making a mistake, of course, because the later questions then take a lot more thought and effort to come up with. You'll have more time to think about. Let's get on to problem number 2. So continuing on, we are on to the fall 2021 10A problem 2, also the 12A problem 2. There were a lot of the same questions between the two tests in the first 10, I think like 7 or something like that. I don't know, we'll see. Menkara has a 4x6 index card. If she shortens the length of one side of this card by 1 inch, the card would have area 18 square inches. Let's think about that. If you took an inch off of this dimension, it'd be 4x5. That's not it. Must have been the other one. 3x6 would be 18. So you would get the 18 that they got. Let's keep reading. I like to process as I read, not read the whole thing. What would the area of the card be if instead she shortens the length of the other side by 1 inch? We already did that. That's the 4x5. That's going to be 20. That's the answer. Let's get on to problem 3. All right, and now we are on the 2021 fall AMC 10A problem 4. It was also the 12A problem 3. Mr. Lopez has a choice of 2 routes to get to work. Route A is 6 miles long and his average speed stop. Why are we stopping? Let's start making sense of what we're reading. Don't read maybe the whole paragraph, just start making sense of it. You should know what we're doing. We're doing rate times time equals distance. This is like a staple of the competition and just math in general. So rate times time equals distance. If he goes route A, it's a 6-mile route and his average speed is 30 miles per hour. So we're going to put 30 here and 6 here. Immediately take this and divide by that. You can do time equals distance over rate. You're going to get 1/5. Okay, but what is that? Well, time, remember the most important thing for rate, time, distance is that the time in units has to match the unit of the rate, right? So this is miles per hour. This is 1/5 hours, okay? So next up, route B is 5 miles long and his average speed, you might want to put B and 5, but hold up just a second. And his average speed along this route is 40 miles per hour, except for a half-mile stretch in a school zone where his average speed is 20 miles per hour. Good. Okay, so let's do B, and then we'll call E the exception. So if it's a 5-mile stretch and he travels one rate except for this half mile, it's going to be 4.5 miles at the rate of 40 per hour. And the exception is 0.5 at the rate of 20. So we're looking for by how many minutes is route B quicker. Route B is basically this combined. What is 1/5 of an hour? It's 12 minutes. 60 over 5 is 12. So A is 12 minutes. Okay, what is B going to be combined with E basically? Do you think 4.5 over 40 is fun? Probably not. And when you feel that lack of enjoyment coming from your calculation, it's a sign you should probably do it differently. So it's not that I know to change this into a fraction, it's that I really don't want to do it with the decimal. So I'm just going to make it a 9 over 2 over 40, which is 9 over 80. 9 over 80, because this is 9 over 2. When you divide by an integer, it's the same as multiplying the denominator. Now that's not nice in terms of minutes, but I'm over it. Okay, then 1/2 divided by 20 is 1 over 40, but we're going to make it 2 over 80 so that it plays well with the other value, because we're going to add those together. It's going to take 11 over 80 hours. Again, you're adding those together. We're going to multiply that by 60 because there's 60 minutes in an hour. You're kind of doing a unit conversion or a conversion factor if you don't know. And then this is hours, right? And so the hours cancels the hours. It leaves you with the minutes. So 60 over 80 is 3/4. That's 33 over 4 minutes. How am I getting 33? It's the calculation of 20 goes into here 3 times, times 11, 33, and then 20 goes into here 4 times. So B is faster. We just need to take this, convert it into something over 4. That's going to be 48 over 4, subtract 15 over 4 equals 3 3/4. 3 3/4 minutes faster on route B than route A. Let's get to problem number 5, or 4 if we're doing the 12. And so the last problem of the 10A first 5 rapid fire is this problem. It's only the 4th problem for the 12A. We'll do that one in a moment. So the 6-digit number 20210A is prime for only 1 digit A. What is A? Well, it needs to be prime. Prime numbers only have 2 divisors, 1 and itself. They have to be unique. 1 is not a prime number. But that doesn't matter here. So A cannot be even because even numbers are all divisible by 2, the only even prime being the number 2. So what do? You should know your divisibility rules, right? I mean, early ones, especially less than maybe 11 and below, you should know how to evaluate if a number is divisible by those. So for example, if it ends in 5, it's divisible by 5. These are concepts we learn in AOPS pre-algebra even, and yet you're getting one of these on your AMC 10 and 12. Hopefully you guys flew through this one, and if you didn't, lessons learned, we need to know our divisibility rules. So what's next? I think about easy divisibility rules. If it's a multiple of 3, the sum of the digits is a multiple of 3. So let's add up all the digits. 2 plus 2 plus 1 is 5 plus A. Now if A is 1, 4, or 7, all such results will be multiples of 3, right? 5 plus 1 being 6, 9, and 12. Since the sum is a multiple of 3, so is the original number. Now of these, 1 and 7 are odds, so they are out because those numbers would be divisible by 3 and hence not a prime number. Okay, so then what about 3 or 9? We're down to these ones. Well, we've already exhausted 3 and 5. Divisibility by 7 is kind of hard to check. You might as well just do the division, and I don't really want to do that. But we know a cool trick for 11. And if you didn't know this one, you should, and maybe add it to your small notebook if you weren't aware of it before now. You want to do every other digit, add up all of those, so 2, 2, and 0. 2 plus 2 plus 0 equals 4, and then the other digits that you didn't include the first time. 0 plus 1 plus A, which I'm just going to write as 1 plus A. Now, if the difference in these two calculations is a multiple of 11, including 0, because 0 is 11 times 0, or it could be 11, it can even be negative. Now we're not going to have 11 or negative 11 here because it's just too big of a difference for us to get, but we can easily get a difference of 0. And if you get a difference that's a multiple of 11 with the two alternating digit sums, it is divisible by 11 and hence not prime. As you can see, if A takes on the value of 3, this is 4, the difference being 0, that means it's not 3, and we only have one answer left. So it's got to be that by process of elimination. You really don't want to check that to see if it's prime, trust me. And you're just going to have to ride with it and hope you didn't make a mistake in your reasoning here. So be careful with the reasoning that you did. We are on to the next problem or the next set of 5 if you're following the 10A. All right, continuing on to the first problem of this rapid fire video. If you're watching the 10A, it was problem 6 from fall 2021. It's the last problem of the 12A from the same test. If you were timing yourself during this test, I did check my time. I timed myself taking it to see how I would do. I did check my time, and when I started this problem, I was right about the 6-minute mark. And to be honest, that's probably a little bit slow. I got hung up on that 3 longer than I would have liked. It would be better if it had been 5 minutes. Every test is different though. You'll be slower or faster than this depending on the difficulty of that year. So Elmer the emu takes 44 strides to walk between consecutive telephone poles on a rural road. Well, good that it's rural unless you usually see emus in the city, right? So they tell us that. It's very important, yeah? So Oscar the ostrich can cover the same distance in 12 equal leaps. The telephone poles are evenly spaced, and the 41st pole along this road is exactly 1 mile, 5,280 feet from the first pole. Now, this particular situation where you've got like pole, right? If you have a number of evenly spaced poles, if there's 4 poles, for instance, then the gaps are the distance. There's only 3 gaps. So hopefully you didn't divide by 41. This is a common setup. There's been several times it's come up on AMC 10 and AMC 8 in the past. So if you haven't done a lot of past tests, including AMC 8s, you might have been at a disadvantage on this because it took you longer to think of that. The rest of us were able to look at this because we solved so many past problems, and we just go, there's 40 gaps. So what I want to know is what's the distance between each pole? I'm going to find that out now. It's 5,280 feet divided by the 40 gaps. And we're going to find the feet per gap. So I'm going to divide the zeros out immediately. 4 goes into 500. I go in reverse when I divide, not the other way. 4 goes into 500. I'm basically thinking of it like this. It goes into here 125 times. It goes into there 7. 125 plus 7 is 132 feet per gap. Okay, and obviously if I'm solving, I'm not explaining what I'm doing. I just do the work. Okay, so 132 feet per gap. Okay, then let's see if these play well together. If it takes 44 strides for the emu, okay, then we want to do 132 divided by 44. Now I'm going to put it as 4 times 11, but actually I don't need to do that. It's just 3. You should be able to see that. But if you can't, 11 goes into 132 times by 12 times, and you should know that. Thanks, times tables. 4 goes into 12 3 times. So it's going to take 3 feet per step, or whatever it is. He's doing what? Strides. So he's got 3 feet per stride, okay? For the emu. This is the emu calculation. All right, now, the gap between the poles doesn't change for Oscar. He's going to have the same gap between his 2 poles. So he's got 132 feet, and that's per gap. And he only takes 12 leaps to cover that gap. We already know it goes in 11, so he gets 11 feet per, leap. 11 feet per leap. So the difference between him and the emu is going to be 8. Let's see what it says. How much longer in feet is Oscar's leap than Elmer's stride? 11 to 3 is a difference of 8. Answer choice B. Let's get to the next problem.